So welcome, welcome students. Today we will continue our lectures on the IEEE 802.15 standard. So in the previous lecture video, we were talking about the the Bluetooth standard, which is part of 802.15, and that was 802.15.1, and we saw what are the different technology specifications and options that you have as a part of the standard for Bluetooth. So today we will continue our discussions, and we will see what are the other forms of technologies that are supported as a part of this 802.15 standard. So basically after this 802.15.1, work went in two directions. So one was the 802.15.3, and this had higher data rates compared to your 802.15.1, but still this was low cost and low power as compared to the other another IEEE standard, that is 802.11, which was for Wi-Fi that you have studied previously. And then the next direction was 802.15.4, and this was very low cost, very low power, and also low data rate. Okay, low data rate compared to 802.15.1. Okay, so let's look into more details of this 802.15.3 and 802.15.4. So here is the 802.15 general protocol architecture, and you can see that this brown part is mostly your Bluetooth. This is Bluetooth 802.15.1. You have a MAC layer, and then this is the physical layer where it mainly operates in the 2.4 gigahertz band with 1, 2 or 3 megabits per second. For Bluetooth high speed version you can go up to 24 megabits per second. And then these are the two other parts of the 802.15 standard. So this is the high data rate version 802.15.3. So we have 1 to 6 gigabits per second. So notice the difference, megabits versus gigabits. And for this you have 100 gigabits, so as high as 100. And also notice that they operate in a different spectrum band, the 60 gigahertz band. So these are the different again parts of 802.15.3 with different data rates, but generally speaking these data rates are higher. So 802.15.3 is mostly dealing with the high data rate versions. And then 802.15.4, again this operates in the almost in the GSM band, 868 to 915 megahertz. It also operates in the 2.4 gigahertz band, and then it can have data rates of these. So you can see these data rates are relatively lower, of the order of kbps and megabits per second. So with different again different technologies in the physical layer like DSSS, UWB and CSS, you have different different data rates here, but they are still relatively low compared to these, or even the original Bluetooth 802.15.1 standard. So So yeah, so moving on, this picture also shows you the relative comparisons of data rate and the range of these different 802.15 technologies compared to 802.11 technologies. So as you saw in the previous video lecture, as an introduction to this 802.15, they were mainly meant for wireless personal area networks. So you have Bluetooth here, Bluetooth high speed is also here, and then 802.15.3, which right at the beginning of this lecture video, as it was told that the work went in two directions. 802.15.1, this was Bluetooth, which is here, and then as you see, these are the data rates that Bluetooth can provide, and obviously the range is very short, of the order of 10 meters. And then after this, as you saw in the very first slide of this lecture video, that the work went in these two directions, 15.3 and 15.4. So here are your 15.3 technologies. They are relatively high data rate. So the range still remains within 0 to 10 meters. And then you have the 15.4 here, where the data rate is much lower compared to Bluetooth and all these technologies. And this is also low range and very low power. Okay, and this technology is called ZigBee. Okay, again the technical name is ZigBee. Just like 802.15.1 was known as Bluetooth, this is known as ZigBee. So again, this 15.3, 15.4, including 15.1, whatever, they all are parts of wireless personal area networks. So they are WPANs. And then your WLAN, which you studied previously, they all are part of this 802.11 and its different versions. So these are all Wi-Fi, and the speed of Wi-Fi is in the mid range. Okay, in terms of the data rate. Okay, it can be somewhere between 54 to 600 megabits per second. These days we also come across the term gigabit Wi-Fi. So this is again a new technology which, if you want, you can look up about this. And then the range of WLANs is always higher, in the order of hundreds of meters, few hundred meters. So this picture actually summarizes the comparisons of these different wireless technologies very nicely. So talking about 15.3, so this is the high data rate version, right? High data rate version. So this is high rate WPANs, and they are used for connecting digital cameras, speakers, video and music. Okay, so so basically the different parts of this technology are there, and one of them is the Piconet coordinator. Okay, so the Piconet coordinator basically sends beacons to devices to connect to the network. Okay, so this is kind of similar to the Bluetooth master as a part of the piconet. So Bluetooth also had a piconet, and then within that piconet there was this master and then a slave. Okay. So here also, as a part of 802.15.3, you have a piconet coordinator which has kind of similar functionalities as the master of the piconet in Bluetooth. So this piconet coordinator sends beacons to devices to connect to the network. So beacons are some control signals, okay, some control signals. So they are sent by this piconet coordinator to connect to the devices, and they also use super frames like the 802.11 standard. The QoS is based on TDMA, time division multiple access, and the piconet coordinator controls the time resources but does not exchange data. Okay, so this is a picture that will explain what is happening. So you have multiple devices as a part of this 802.15.3 technology, and then you have the piconet coordinator, which can also function as a device, by the way, and then it sends beacons to all these devices, okay, to get connected, okay, and then the device exchanges data between themselves, okay. So the exchange of data is bidirectional between devices, but the beacons are only unidirectional. As you saw, it only goes from the piconet coordinator to the devices. And the piconet coordinator, they don't exchange data, but sometimes they can also function as a device. In that case, they will exchange data. So here in this case, okay. So this is your 802.15.3. The latest standard is 802.15.3c, but when this slide was made few years back, at that time it was this, which was the latest standard. This might have updated, so you can again look up in the internet and find out whether this indeed is the latest standard or something new has come across. So 802.15.3c, this uses the 60 GHz band with same benefits as 802.11 AD, single carrier and OFDM physical layer modes. This phi stands for physical layer. So now the 802.15.4, which is again, as we started this video lecture by saying that there were two directions, 802.15.3 and 802.15.4. So now let's see what is 802.15.4. So this is low data rate, as we saw already, and low complexity. Okay, so this technology is basically a competitor to Bluetooth Smart. The 5 options that are available in 802.15.4 are these. So you can operate in the GSM band, which is these frequencies for data rates of 20, 40, 100 and 250 kilobits per second. You can also operate in the 2.4 gigahertz band with 250 kilobits per second. You can operate in the ultra wideband mode also. This uses very short pulses with wide bandwidth. and you can have 851 kbps and optionally all the speeds. Um, Sometimes this 2.4 gigahertz chirped spread spectrum for 1 megabits per second is used, and optionally for 250 kbps also. So again, I will cover what is spread spectrum later in this semester, but chirped spread spectrum is something which is beyond the scope of this module, but I will not discourage you to look up again and read more about this if you are interested. So basically, the chirped spread spectrum in one line means that the sinusoidal signals that change frequency with time identical to frequency hopping. Okay, so again, frequency hopping you have already seen when we were discussing Bluetooth. So there are many other versions of this 802.15.4 standards. So for example, 802.15.4f, which is for RFID tags, and these are very much used in tracking different assets. For example, the books in a library or the items in a supermarket, they have RFIDs, and if you are checking out without proper authentication, then there will be an alarm ringing. Okay, so this is the usage of RFIDs. Then you have 802.15.4g, which is for smart utility networks. So for example, the smart grid network. Okay, so these are electrical energy networks with some intelligent and smart switching functionalities. 802.15.4j for medical body area networks, 802.15.4k for low energy critical infrastructure networks. So for example, when you have some monitoring devices that needs a very long battery life, okay, for example, some sensor devices in mines, okay, or in remote forest areas, etc., where it's difficult to replace those sensors. You have these type of low energy critical infrastructure networks. And 802.15.4, as you already saw, there are variants of 802.15.4 which are really low energy, and then this 15.4k is again even lower energy, which is specifically suited for this. You can have 802.15.4p, which is for positive trend control. So you can have different sensors, and then you can do a lot of signaling with the help of them in rail transit system. So that is we have a standard for that also, and that is 802.15.4p. So there are other 802.15 standards also. For example, 802.15.2, which is a coexistence between 802.11 and 802.15. You have 802.15.5 for mesh networks, 802.15.6 for body area networks, and for visible light communication you have 802.15.7. So we will focus a little bit on 802.15.4, which is the low data rate and low energy and very short range application, and that is sometimes also called ZigBee. Okay, This operates in the ISM bands, so 868 megahertz for Europe, 915 for US and Australia, and 2.4 gigahertz worldwide. And this has some functionalities like quick wake from sleep, so it takes just 30 milliseconds or less to be in the active state from the sleep mode, whereas Bluetooth can take up to 3 seconds. So ZigBee nodes can sleep most of the time, and because they can take very less time to wake up, they can be quickly waken up and made operational. So ZigBee complements the 802.15.4 standard by adding 4 main components. So in the network layer of ZigBee, there is a routing functionality. Okay. Then there is an application support sublayer that supports specialized devices. And then these ZigBee device objects, these are the most significant improvements. Okay, so these are helpful to keep device roles, manage requests to join the network, device discovery and security. And here another feature which again is also important, it allows customization. Okay, so manufacturer defined application objects allow customization, so you can customize and reprogram the ZigBee applications. Okay, so here is that part. So this is the basic ZigBee architecture. So you have in the application layer, you have this application objects which are end manufacturer defined. Okay, but you can also customize these. Okay, you have the ZigBee device object, which is one of the additional functionalities of ZigBee, as you saw. And then the application support sublayer, okay, does lot of new functionalities, the most important being the security service provider. Okay, and in the network layer you have this special features which manages the routing. Okay, and then there are many other sub functions also. We have the usual MAC layer and the physical layer. Okay, so again this is a very high level diagram with a gist of the ZigBee architecture. The details are again given in the book by William Stallings, which is the main textbook that I am prescribing for this module. So you are encouraged to go to the chapter on ZigBee and see the details of each of these blocks. Okay, in terms of the actual network architecture, ZigBee can have different types. It can have star, tree or general mesh network architectures. So mesh network, this is a new architecture that you have not come across so far in all the standards that you have been studying. So this is a specialty of ZigBee, and the routing functionality is mostly important when you have a mesh network. Okay, so that's why ZigBee network layer adds this network add this routing functionality. So among the different devices in a ZigBee network, the categories can be 3. So one is the ZigBee coordinator, the other one is the ZigBee router, and the third one is the ZigBee end device. So ZigBee coordinator, basically this is the main device, similar to, let's say, the master in case of Bluetooth, or let's say PNC, Piconet coordinator in case of your 802.15 15.3, or let's say the control module in case of your Wi-Fi. So this has the same functionality. It creates, controls and maintains the network, and only one coordinator in the network should be allowed, and it maintains network information such as security keys, etc. Then you can have the ZigBee router, which can pass data to other ZigBee devices, and the ZigBee end devices, they only have enough functionality to talk to a router or coordinator. Okay, they are much less complex. They cannot relay information, they sleep most of the time, and less expensive to manufacture. Okay, so all the main functionalities are performed by these two types of devices. These are very low complexity, low power, and they only have a basic functionalities like talking to a router or a coordinator. So these are the examples of the different topologies that ZigBee can support. So this is the start topology. These are the ZigBee end devices. You have the ZigBee coordinator here. You can have tree and mesh topologies. So in case of tree, you can see that you need some routers intermediate between the coordinator and the end devices. Same is true for the mesh network. And whenever you have a complex networks architecture like the mesh, you can see that routing becomes very important. Okay, so ZigBee added the routing functionality in the network layer just because to support these this mesh, and also to some extent these tree topologies. So again, we have a ZigBee alliance. So this is again, you saw in case of Wi-Fi, you had a Wi-Fi alliance. In case of Bluetooth, you saw that there is a special interest group. So all these consortiums, these are industry consortiums, and they exist because there has to be some interoperability. Okay, there has to be some universal operational standards between the devices manufactured by different manufacturers. So same functionality is provided by the ZigBee Alliance. So this maintains and publishes the ZigBee standard, and it also creates and maintains different application profiles. So these application profiles allow vendors to create interoperable products if they implement the same profile. So interoperability is the key word for all these industry consortiums. So there are different ZigBee application profiles that can exist. So let's say for building automation, for healthcare, for home automation, for input devices like wireless mice, keyboards, touchpads, etc. ZigBee Lightlink, ZigBee Network devices, in smart shopping and retail services, remote control, smart energy, in telecom services. So there can be many applications of ZigBee in Internet of Things type of applications, and I'll show you a video right after this to emphasize this aspect of ZigBee. Okay, so I'll stop here for today. Following up is a video on ZigBee, and that after that video, this video lecture will end, and I will see you in the next lecture.
Welcome to CES and the ZigBee Alliance Pavilion. Our members are here this week displaying products and services based on ZigBee, the original and only open global wireless standard that can conveniently and affordably connect the widest range of devices to improve comfort, security, and convenience for consumers. ZigBee is the only standards-based wireless technology designed to address the unique needs of device-to-device communication in just about any market, and it is particularly suitable for the smart home. ZigBee uses mesh networking to eliminate single points of failure and expand the reach of networks. With mesh networking, when you increase the devices in a home, your network becomes much more reliable. ZigBee is low power, allowing battery-operated devices such as door and window sensors to operate for up to 7 years. The green power feature even allows you to have devices with no battery at all, such as this light switch, which is powered by harvesting the energy from a button push. A ZigBee-enabled set-top box like this one, or a gateway in your basement, can be the starting point for your smart home. It connects the devices throughout your home and provides a cloud connection for services such as security monitoring, or allow you to control and monitor your home from anywhere in the world. The set-top box is often controlled by a ZigBee-enabled remote control. And you can use your television screen as an interface to control the other parts of your smart home. Remote controls that use ZigBee do not require line of sight, so set-top boxes can be stored in fashionable furniture, out of view of your guests. ZigBee has advanced features for remote controls that allow innovative designs, such as using motion sensors to browse on-screen content or change channels and volume simply by waving your remote. No button press needed. There are even Find My Remote features to come to your rescue when the remote control is lost. ZigBee enables a variety of smart home applications. You may be familiar with traditional security systems that include door, window, and motion sensors to detect a break-in. But with ZigBee, your security system can be extended to include a variety of sensors around the home to increase your peace of mind. For instance, smoke, carbon monoxide, and even water leak detectors can be connected and immediately alert you or a monitoring center when they detect dangerous conditions. Discovering a water leak early can save homeowners very costly repairs. Connected lighting is a rapidly growing segment in the smart home. ZigBee lighting systems allow you to turn lights on and off automatically to save energy or provide advanced controls with your television or smart home. These advanced connected lighting functions are allowing consumers an unprecedented level of comfort and convenience. Connected lighting enables many interesting applications, such as configuring your living room to watch a movie. You can dim or turn off multiple lights with a single button press. Connected LED lighting not only improves energy efficiency, but also improves control over the color of lights, providing new ways to decorate your home. ZigBee's ability to connect and control lights is the reason it was chosen by the Connected Lighting Alliance, a group of global leaders in the lighting industry, as their preferred standard for residential lighting applications. ZigBee Alliance members around the world are working to deliver innovative and affordable products for all areas of the smart home, including healthcare and energy management. Thank you for joining us here at the Consumer Electronics Show and on learning more about how ZigBee can help you control your world.